So welcome to BCS ICT Ethics Specialist Group. Today's event is our annual general meeting. But to add more interest to that and to act as an opening to this, we're going to start with a talk from one of the Ethics Specialist Group members, Don Gotterbarn. We'll talk about computing ethics lifecycle, closing responsibility gap for the ethical IT professional. So roughly that will go from now till around 3 o'clock, and then we'll aim to have the AGM. So without further ado, I will pass over to Don. Thank you.
Thank you, Neil. I want to thank you and the BCS for the opportunity to talk about the ways to address some of our ethical challenges in computing. As an official elder of the ethics community, I'm required to engage in reflection. Recently, I wondered why anyone pursues a career in IT. It's hard. You need to address changing requirements, systems crash, and nobody does COBOL anymore. But then I realized the job actually has some satisfaction in solving complex problems. We engage in purposeful, goal-oriented action, not just busy work. I've been lucky constantly encountering fresh situations in my work as a software engineer, lucky to work on a variety of interesting systems. Some of these tasks involved critical decisions. Some decisions had mandated parameters of stay within budget, be first to market, and maybe if you have time, protect the system from hackers. I had an opportunity to use my skills in positive ways as a practitioner and as an academic, working toward common goals with other IT professionals, trying to do a good job, not hurt people, maybe even contribute something positive. This goal, to do something positive, is the first principle in many professional codes of ethics. The BCS Code of Conduct describes its purpose as a professional body, the BCS has the responsibility to set rules and professional standards to direct the behavior of members in the profession. And the BCS Code's first guidance principle is to protect the public. There is a common code of ethics shared by ACM and IFIB, which has a similar first principle. It's not always easy for us to determine the best decisions in IT. We're asked to do complex things and integrate those actions into diverse environments. To help us, the Common Code of Ethics also includes guidance principles about how to apply each principle in practice. Some of my projects involved significant, unanticipated ethical adventures. Data indicates that many others have similar difficulties recognizing the impact of their work until it is too late. To reduce these difficulties, there are some concrete strategies and proactive interventions to help us notice significant ethical challenges and evaluate ways to address them before they lead to disaster. Professional codes of conduct and ethics are supposed to help here. Sometimes we actually look at codes of ethics for guidance, but sometimes codes of ethics are treated as interesting lists, maybe shelf paper. Let's look at an old major corporate decision that was made in spite of a code of ethics. In the 70s, in response to the influx of Japanese small cars in the US, Ford Motor Company designed the Pinto, with the primary goal being to get the product out of the door fast to compete with this new small car market. But because they placed the fuel tank in front of the rear bumper and behind the rear axle, fires resulted from minor rear-end impacts. Ford neglected to add reinforcements to protect the easily ruptured fuel tank. What explains Ford's decision not to add these reinforcements? We know Ford's thinking from emails that have been recovered. They anticipated about 180 deaths as a result of the fuel tank fires, and maybe 180 injuries from burns. Fixing the problem would cost an additional $11 per vehicle, and Ford weighed the total $137 million cost for fixing the problem against the projected $49 million payouts for death and injury. So they opted for death and injury, and Pinto went into production in September of 1970. The jury did not consider this decision a good decision. And in fact, Ford was fined more than it would have cost them initially to fix the problem. This is an old case. Certainly it wouldn't happen. Volkswagen emissions case, where the engineer wrote software to hide dangerous nitrous oxide emissions for their diesel car. That action let the car pass emission tests, but later, the actual nitrous oxide release of those cars was calculated to have caused at least 60 deaths and thousands of health injuries. The software engineer in charge was fined $250,000 and sentenced to 40 years in prison. Well, these are actions of bad people and don't have anything to do with us good people. We do software, we do IT. And besides, I'm a good ethical person, well trained in ethics. Ethics is second nature to me. I was trained by everybody. For many people, the right thing to do seems obvious. Our ethics starts with past experiences, from things learned from parents, religious texts, constant social cues. And also, I have special software engineering skills, so I am a professional. Having these skills makes me a certified professional in my area of computing. I follow the BCS codes and the AGM codes. I practice computer ethics and understand that computing is an important service to society. As professionals, we support shared professional values that are included in many professional codes. A study of all professional codes of ethics shows that they share these 9 common values. Even though these values are embodied in codes of ethics, we have cases like Pinto and Volkswagen, and the Post Office Horizon scandal, and the Royal Mail software scandal. And what is the problem in following codes? Let's look at codes. Professional organizations make following their codes a requirement of continued membership. People think of codes as lots of thou shalt nots. Don't you do that. A violation of the rule is reason to expel, to excommunicate, to get you out of our society. Punishment is really a secondary role of codes. Their primary role is actually to help guide us in our professional decisions. They're supposed to help us make technical decisions consistent with professional obligations, especially in those cases where we contribute to society, like working on pacemakers or programming the Bluetooth of my defibrillator that's sitting in my chest, or doing laparoscopic surgery systems. In computing, there seems to be a resurgence of ethics concerns with every new technology hype cycle. There has been new computing ethics awakening, for example, in AI. Even with this new awakening, there are some remaining problems from earlier ethics awakenings. In the early days, it was hard to convince anybody that there were ethical issues in computing. Last century, in the 60s, the expression software engineering crisis was common. The response to this crisis included a move to new processes that ensured developers would adhere to the requirements, believing that that would lead to better, less harmful software. Programming languages that helped reduce errors, both syntactic and semantic, would lead to less harmful software. The message was clear. To become a better computer professional was to be certified in the skills you needed to implement the software, precisely as stated in the requirements. In those days, there were even formal proofs of the requirements. The shortcomings of these earlier ethical awakenings is that nowhere in the process was the computing professional allowed to, let alone encouraged, to question the requirements of a software system and what their potential impacts might be. The constraint, meet the requirements regardless of what you may think, was even incorporated in the 1992 Code of Ethics that I helped write. We will see how this problem resurfaced in each new technology hype cycle. We have common goals. There are some genuinely bad people in the world, but I believe that we seem to have a common goal in most of our work. We only seem to identify ethical issues when we think of extreme cases like the Pinto Volkswagen, or maybe the suicides related to the post office software scandal. We don't have to worry about ethics in our day-to-day projects. They're not safety critical. Our job is just to make the software work as specified. Computer-controlled software has done some wonderful things. A good developer will anticipate all software difficulties in such surgeries. Sometimes known errors generate incomprehensible error messages in inappropriate contexts. The competent completion of this software system has met all of its technical specifications, but it was a failure because it did not meet the less obvious ethical requirements. Software was developed to control a radiation-generating X-ray machine to remove tumors. Settings were complex, so the settings were made and were checked, and if they were too high and dangerous to the patient, could be canceled if in the slightest problem with an error. They used a standard keyboard interface. Press X to fire the X-ray, press C to cancel. And it worked exactly as specified. It worked exactly as specified. 6 people died of radiation poisoning because of the proximity of the X and the C on the keyboard. Systems analysts ignored the context in which the system is used, a dark room, a busy schedule. In good times, I frequently make that life-critical mistake. Type an X instead of a C. I did that even as I was writing this example. Not considering all stakeholders is especially dangerous for any human-facing software. Understanding how real people in real situations will respond to the software and its behavior is no small feat. Here is another software that failed to consider the context. In the design of a cockpit interface, a mixed mode display unit was used to show 2 different pieces of information about the descent path of an airplane. The vertical speed at which the altitude is changing and the flight path angle, the FPA minus 3.3, would indicate that it is moving at an angle of minus 3.3 degrees. Wow. There we go. While minus 33 vertical speed meant the plane was losing altitude at 3,300 feet per minute. In a plane crash in Italy, Evidence indicates that the pilot misread the data and probably did not notice the presence or absence of a decimal point. It's not easy for anyone to see the presence or absence of a decimal point in the complex environment of a cockpit. The values of the cockpit gauge were correct, but the interface made the information difficult to discern. Working on these life-critical systems should raise our ethical antenna. Sometimes people get upset listening to examples like these because they, as good moral individuals, think these situations are irrelevant to them, or they are certain that they would think about ethical issues in these extreme critical situations. Ethics isn't always about extremes. I don't know if this happens to you, but when someone hears I work with computers, they immediately launch into a list of problems that they have with computers. Their assumption that all computing is a problem and bad is very irritating to me. I loved computing. I especially appreciated what a computer can do when I had computer-controlled eye surgery that prevented me from going blind. I loved the Kindle, which could change font size for me so I could read immediately after surgery. Just touch the size letter that you could see, and the font size would change. It worked. If your vision was good enough to find the key on this keyboard that had an upper and lowercase key on it that would provide you access to the font changing screen. Useless if you were visually challenged. All these systems did their specified job. By requirement standards, they were completed, but they were failures. We are ethical. Why is there such a problem with this? As we said, for many people, the right thing is obvious to do. Our ethics starts with past experiences, from things we learned from parents and so on. However, issues of computing ethics and other professional ethics are often new and require thought that's not familiar with us, with our simple responses. Few religious texts that I know of mention X, formerly known as Twitter. And I don't think your parents warned you about having AI use everything found on the web to train machine learning. Even though we are good people, we don't have clear ethical answers to many decisions. We're told to worry about budget, schedule, requirements function. In cases we've looked at, I bet the work was the result of qualified technical people who did not think of any ethical issues. Their purposeful action was like crossword puzzle solving. Just get it done, get it out the door, move on to the next puzzle. Many things contribute to these sort of problems, but I think if we address two of them, then we might mitigate some of the results. In Talk on Professionalism in Computing, Tom DeMarco describes a position that often leads to ethical issues. He called it the fatal premise. He didn't use that tone. Often people believe evil is done by evil people. I'm not an evil person, therefore I don't do evil. Professionals who take this view into the world go in ethically unprepared and may simply complete a system without taking the extra time to consider its impact on a broad range of stakeholders. Psychological studies of ethical decision-making show that DeMarco's fatal premise is common. This premise is unfortunately nurtured when an organization puts its primary staff development focus on technical skill acquisition, training on how to consider the impacts of technical decisions on society is at most an afterthought. Without consistent training and considering the impact of technology on people, significant issues may be missed. Sometimes computing systems fundamentally change the nature of the ways we do things that we did not consider. These are not deliberate decisions we make, but these changes are encouraged by the technology we develop. There are some problems with decision-making in general besides this fatal premise that are more subtle and difficult to recognize. Ethics has been discussed by philosophers for thousands of years, but for us, applied ethics is simple. What is its positive, negative impacts on others? Most of our professional decisions have impacts on others. If there is a significant negative impact, then what we do is we look back in the cause for accountable, blameworthy coders, the Volkswagen software engineer sentenced to 40 years. We think ethical judgment is improved by looking backward to find the villain. This is a mistaken approach to ethical reasoning. AI is repeating some of this problem. AI is used in medical diagnostic software, and it's quite impressive. Decisions are frequently better than the decisions of physicians. But there are concerns with AI, including overgeneralization and so on. AI's ethical responsibility is treated similar to those earlier awakenings, looking for someone to blame. Some assert that maybe AI is special in that there is a responsibility gap. That is, the content and the context changes the output we planned, so you can't blame the designer for results. In his analysis of responsibility, American philosopher John Ladd spoke of something called negative responsibility. That was backward looking through a series of causal chains to locate the individual who was the direct cause of an unfortunate incident. This was a responsibility assignment after the fact. Find the programmer who left out the comma that destroyed the Mariner mission. Follow the coding chain to the programmer, or follow the chain to the customers whose requirements were ambiguous. Training data takes on a substantial role in the programming process for AI. This moves us away from this causally linked chain for rule-based programs to programs that actually obscure the transparency of the decision process and that lead to particular outcomes. System decision-making contributes to an alleged responsibility gap. There is no one to blame because of this gap. Let's look at the connections involved in this kind of discussion about a responsibility gap. There are physical connections. We see an action A that causes B, that causes C, and the disaster that you have to run away from. Negative responsibility, that happens when some unfortunate event A causes a problem, and we can go back and use the language to trace back all of these discrete events. Causal discrete chains. But when you look at the BCS Code of Ethics, when you look at the ACM Code of Ethics, there's some other thinking about more than causation when we talk about moral responsibility. The physical causal chain gets obscured by software, yes, but we can think through the actions of the software and point to who wrote the bad cause. But the physical causal chain doesn't give us enough to consider software in context. It certainly doesn't address software developed through techniques such as machine learning. Things like codes of ethics help us to consider broader contexts where we bring together the needs of others and our moral obligations into our analysis. There are at least two types of mistakes in this thinking about a moral gap. Besides this narrow blame contest of looking back, the concept of a gap involves two different kinds of chains. One is a causal chain of discrete events. The other is a moral chain with a moral connection of events. And this we would consider a category mistake in trying to equate these different kinds of events. John Ladd gives a second meaning to responsibility that's critical. There's a positive sense of responsibility that includes proactive consideration of what we ought to do. This is forward-looking, and it has multiple possibilities to achieve the resulting goals. Unlike negative responsibility that tends to be a direct causal chain going backward, positive responsibility looking forward has to adjudicate between multiple chains. Ladd argues that pointing to technology as a primary cause of harm doesn't remove the practitioner from this positive sense of responsibility. A professional is not merely a technician, but someone who additionally is responsible for exercising a higher order of care for those whom their work impacts. This is positive responsibility for what ought to be done. Since there's no causal chain just yet, the system, language, and responsibility gap we're talking about, this gap is wrong. And it frequently diverts attention to this focus on a gap, diverts our attention away from positive responsibility. By turning our attention away from positive responsibility, from the responsibility gap toward positive responsibility, we can more effectively address problems in ethics. Exercising positive responsibility is future pointing. We don't have a clear physical cause of the chain yet. There is a loose linkage that we work with. There are multiple possible causal chains, and there is a problem identifying these, which is your best causal chain, and how you will do this. We're not talking about causal chains. We're talking about our obligation, and the question is, how do we determine our positive responsibility and exercise it? One way is to identify moral obligation is to look at codes of ethics. The code of ethics I have been referring to is an ACM product that was the result of multiple years of consultation with international organizations like BCS, IFIP, the IEEE, and other international bodies and companies. They published multiple drafts of the code, and feedback of those drafts was fed into all following drafts. The code is forward-looking, it's aspirational rather than canonical, based on technical requirements that are outdated as soon as they're written. If the code were to represent the values of a profession, not just a society, its acceptance was more likely to be achieved by various international groups that make up the ACM. It provides tools for making ethical judgments and focusing on ethical opportunities. Consistent with the professional obligation to exercise a higher order of care for those impacted by our work, the public good was made the primary element of the code. This code was adopted by other organizations and IFIP, such as IFIP, representing 54 national societies and regions. When it was reviewed by the BCS when IFIP proposed accepting it, the BCS said that the BCS Academy of Computing has reviewed the proposed IFIP Code of Ethics and will be pleased to endorse it, finding it very robust document covering a variety of important and interesting topics. One way to address the problem of identifying positive responsibility and exercise it in particular situations is to use a code representing the conscience of the profession and use a heuristic for applying the code's principle. A heuristic which is forward-looking and proactive rather than backward-looking and assigning blame. The code is an aspirational guide that invites professionals to contribute to society in ways that minimize unintentional ethical mistakes. We have good evidence that the code represents shared values. It was the work of 3,000 folk. Internationally, it received a 94% approval rating on surveys amongst these groups. It was adopted by over 500,000 professionals represented by IFIP. Now you have the code. Now you have to figure out how to incorporate it into professional practice. There are skills needed to determine how to do that. To adjudicate between possible directions, we need the ability to identify extended stakeholders so that we avoid the fatal premise. We need to correctly identify the potential for ethical problems in a particular context. We need to identify the causal issues, alternate causal chains. And then when we get this array before us, we need to select the technically and morally workable direction to go. But there's a second moral problem. In addition to the fatal premise, there is some psychological characteristics that contribute to our failing ethical decisions, and we fall into certain traps. One of the ways we manage complex problems in computing is divide and conquer. We narrow our focus to each complex element of a problem. This allows us to frame out distractions, and that's a plus. But we know in our daily lives that mistakes are often made because we ask questions constrained by a particular frame or filter. For example, many communities felt the environmental moral responsibility to introduce recycling programs. It happened to bring in some money. Well, now recycling brings in less money or even costs money. If moral responsibility is framed out of the question of continuing recycling, and you just look at costs as the overriding driver for decision-making, then recycling will stop because the moral imperative isn't forgotten. If the focus is on winning at all costs, then what's wrong with taking drugs to improve performance? If profit is the primary question, then when we frame out those who will get burned to death in a car crash, okay. Those extreme cases, we're aware of the framing out, but in other cases, we miss it. This framing out of social and ethical issues, when combined with the fatal premise, leaves us engaged in or condoning behavior that we would condemn if we were conscious of it. Avoiding these problems requires some attention to the nature of ethical decisions. This framing out has a psychological basis. Psychological studies have found that our immediate ethical intuitions, this intuitive processing, frequently precedes a real ethical decision, the decision-making that is slower and more deliberate and logical. Ethical decision-making processes take cognitive attention in order to consider the aspects beyond the way in which situations are framed for us. Every line of code we write affects others. ethical deliberation requires an analysis of the impacts to a broader range of stakeholders. Applied ethics is a process Applied ethics is the process of interpreting, choosing, and assessing our activities as professionals. Although people bring different experiences to ethics to their work as computing professionals, being a computing professional is the thing we have in common, regardless of these different experiences. The Code of Ethics captures this commonality. However, it alone is not enough. We need a simple tool to apply this Code of Ethics. To support the code, the ACM developed a code booklet. Before formally adopting the code, IFIP also produced a code booklet. The ACM booklet has some case studies and suggestions how to use the code. The analysis process, CARE, in that booklet was later modified to emphasize the elements of positive responsibility looking forward, and they called it proactive care. With proactive care, individual teams and organizations can increase the chances of ruling out the fatal premise and the framing out problems. A habit that this needs to encourage is for us to always be ethically on guard. This is not a skill to be taken lightly. It takes practice and cognitive attention. Proactive care helps you apply the principles of the code as you make these kinds of decisions, achieving your moral goal. Proactive care. Consider. To help get you started, you need to identify potential ethical issues. And remember that if the software code you're writing is worth it, getting paid for, it's going to affect others. You have to consider whose behavior is going to be affected, whose circumstances are going to be affected. With these considerations, you begin to identify that list of stakeholders you should write down who will be impacted, like the patient under the X-ray machine, the X-ray technician. Looking in this way, you consider and think about other alternatives. A good place to start the analysis of these alternatives is take a look at the code, keeping in mind that it expresses the moral values of a computing profession. Analyze the technical facts of the system and the consequences of each of those alternatives. Review. This analysis leads to the identification now of some trade-offs for each of these ethical alternatives. Review the alternatives. You might think of some new creative ones. And then you apply professional judgment by reviewing potential actions relevant to the principle in the codes. You've reasoned through an international standard. Evaluate what's left. There's likely tension in some of these potential actions. There may not be an optimal choice, merely ones with different trade-offs. But now you know what those trade-offs are. These tensions, they require some stamina to follow through. Furthermore, evaluation should require some continued monitoring. Proactive care is designed to help you use values to reason to purposeful actions. There's no responsibility gap in this problem, in this process. Proactive care guides us to do ethicing. Ethics isn't something you read about in a list, in a code of ethics on a table. It's an action, but it's not easy. It requires deliberation. There needs to be constant focus on the first principles. Common to both the BCS and the ACM, must consider all stakeholders. In its revision of the ACM Code of Ethics, ACM added considering all stakeholders, the gentle reminder, acknowledging that all people are stakeholders in computing. This business of proactive care is useful for individuals, but it's also needed for teams. So we could consider a team approach to this, and considering a simple device, again, like a font enlargement device, but for the Bluetooth software that accesses a surgically installed defibrillator. If responsibilities like this, doing this simple act, fell to a single developer, it would be a heavy lift, especially if they had limited expertise only in technology. Those skills don't translate into ophthalmological knowledge about the potential harm a font might do when someone has dyslexia. By recognizing limitations on their expertise, it's natural to bring the result of their work to the team. The more people who collectively think about what can go wrong, the more likely we are to identify things that need to be addressed in their solutions. Teams need to recognize that computing systems are socio-technical creations. Part of their responsibility is to involve others with appropriate ethical expertise. As developers, we know that testing at the end of a process and just waiting for the end is bad. It should be done all the way through. As developers, the same consistent, regular consideration should be given to ethical issues. Teams need to identify all of the complexities of the problem, recognizing that computing systems as social systems dictate bringing in appropriate expertise. I hope that in writing software for a pacemaker, we would first seek specialized help in determining the duration and the amount of voltage that gets applied to its pacemaker. Analysis of team process is important to show that a team has not been overtaken by the march of competent creation. Analysis also includes careful attention to the framing out problem, which frequently is framing out budget and schedule. The review process, Review processes, when we engage in coding reviews, revolve around looking at technical issues. But reviews should also include, hey, wait a minute, have we thought about this ethical issue? The review system might help us to recognize the impact on a broader range of stakeholders and actually raising some of these ethical issues in a review. Evaluations should not be about ego. When these alternatives come up on a team, you'll have different options for the team, and there will be various tensions that need to be resolved. But what you want to do is look at them and pick the best technical and moral solution. Now, this work of teams is best done when it receives the support of management. The approach I'm advocating includes responsibilities for individuals, teams, and management. Section 3 of the code focuses on the responsibilities that leaders have to support software developers in their professionalism and give the required attention for doing this ethical analysis. When we do this type of analysis, we need to have management support a culture of change. that culture of change has some specific items in it. One is hiring the best person. Now, it's interesting because most commonly the hiring process implicitly assumes the fatal premise. Potential employees, they're hired in, we assume they're good people, they already know ethics. So all we have to ask them about is their technical skills. Can you program this in C? Can you use Python? Can you use Rust? Can you use... But some companies recognize that quality work requires more than technical skills and have introduced new questions into their interview process. Some of these, like I have listed on the slide, ask questions beyond mere technical issues. Have candidates address their commitment to their own ability to be ethically on guard. Give them a problem to see if they're sensitive to an issue about how to implement code. Ask them, what'll happen if we program a defibrillator to run for a certain period of time and force it to turn off for 3 hours? Candidates will give technical responses, but follow up and ask them, what happens to the person who's on the defibrillator when you turn it off for 3 hours? Using these types of questions help hire those who have a sense of moral responsibility. But these technical skills need to be encouraged and rewarded. So they are their standard of ethical, a standard of practice in the code reviews is evaluating the code. And as I said, review sessions can be modified to include proactive impact that promotes positive income and mitigates negative effects on other kinds of stakeholders. Ethicing is hard work. What we ought to do is when we're reviewing I was about to say students, when we're reviewing our employees' work, we ought to look into socio-technical discussions and say, who's going to use this particular device? Who's going to use this, and what will be their reactions to it? Where is that multifunction device for the airplane going to get inserted? It's important for line managers to make sure that their staff is considering these kinds of issues. Here are some simple practices to help you introduce this kind of thing. Use a developer pre-commitment device to mitigate the fatal premise. Have the developer think about what they would be proud of when this system got delivered, and have them write it down. Write it down yourself. What would you like to appear in your project review from your manager? And what would you like to see the customer say about your product when it was delivered? That it was useless to me and I couldn't increase the font size? What would the stakeholders say about your contribution? If you write it down, you will behave differently. If the organization writes it down, things will behave differently. Pre-commitment devices can be used in project plans. Place Principle 1.1, contribute to society and human well-being at the beginning of a project plan. Place some of the principles of the codes of ethics into the project plan. These are things we're trying to do. Use the code. Engage a team in identifying how these principles are relevant. These side discussions are valued by professionals who appreciate your considering their input. There are recent examples of employees who've raised concerns with management decisions, and they've pointed to the ACM Code of Ethics for support. This can positively influence internal decisions within an organization. Avoid the fatal premise and realize that without care, we can easily make ethical missteps. Not bad people, we fall into traps, framing out critical concerns. Being ethical involves considering the impacts of our well-chosen actions on the world. Being as good as we think we are requires us to avoid these mistakes of thinking of ethics purely in terms of negative responsibility and finger pointing, but thinking in the other direction, positive responsibility using common values of the profession applied to our work. We need to foster a culture which encourages rather than diminishes this forward focus. Technology and values interact. This is a lot of work, but I think we make a mistake if we think we can assume we can avoid making ethical decisions. Doing nothing, continuing on, not taking care, is an ethical decision. This is my answer to my opening question about why pursue IT. The real excitement of being an IT professional is this possibility of doing something which has positive outcomes and focusing on positive responsibility. I wish you luck in your adventure. Thank you.
Well, thanks for that, Don, and that's really good timing. So yes, can see lots of virtual hand clapping.